All right, welcome to our presentation. This is a presentation by Ramon Alvarez, which is my research assistant. I am Dr. Timur Mirzoev from Georgia Southern University, and I'll be doing a presentation on cloud computing. Ramon works with me since this summer, 2013, I guess the past summer, and we're doing a lot of provisioning of cloud resources. We do some of the advanced curriculum. I may have some people in the classroom that I've trained. I'm also a certified VMware instructor. I teach commercial students on VMware technologies. So we'll talk about the cloud computing. I kind of have to stay close to the microphone here, but I thought about the presentation and I said, you know, next wave of technological advancement, and I decided to change it to actually the current wave, because I think it's make a note in your notebook. Excuse me. And the reason why is because it's actually not new. And does anyone know how long cloud computing has been around? Like, when was it invented? It's very close, 1961. And that's kind of the same about virtualization as well. So it kind of tells you how long it takes humans to adapt to anything, right? At least 60 years or something. But I also want to start the presentation with the thoughts from you. And this is based on the survey by Citrix. What do you think when you hear cloud computing? And I'll give you some words that appear on the screen and see if we can match that. Let's give me some of your thoughts. You hear cloud computing, what do you think? Cheap? What was that?
Shared services.
Shared services, okay.
Applications running on somebody else's computer.
Okay. Applications somewhere else. Remote access.
Elastic.
Elastic.
DSA.
And what else? So let's see. Some of the words that come up when people answered the survey by Citrix. Innovation. You know, it's true. Since 1961, I guess. But security, I think, is the next word. And it does come to mind, everybody talks about, you know, how secure is your cloud, which is in itself is incorrect question, because you can't really speak of the security of the cloud. You can't embrace the cloud with one security aspect of something. From everything I know about cloud computing, I can tell you that I usually refer to it as the universe, right? So when you poke your finger in the sky, you're probably covering like, you know, 1 billion galaxies with the thickness of your finger. That's the same in cloud computing. You just poke your finger somewhere and you have covered like 2,000 VMs that are sitting on different hypervisors, different platforms, and so on. So, excuse me. I'll try to clarify some of these misconceptions, because there's a lot of them. Cyberspace, right? Somewhere out there, there's something going on. Money, right? Tim just left the room, but somebody said it's, I think he said that's cheap, you know, inexpensive. Let's see, storage. How many times have you heard that people call Dropbox a cloud resource? Do you agree with that in general? It's a shared resource, so if it's a shared resource, you can kind of say that yes, it is somewhere in the cloud, but it's been, you know, as we build these words on the slide, they kind of start to go a little bit off the subject, and you will see that backup is there, also movies, right? You know, every time I watch a movie and they advertise the Blu-ray technology, they'll say, put your movies in the cloud. Right? Again, I don't agree with all of these terms because they've been abused too much. Mysterious network. How about that one? Use it next time when you teach cloud computing. Unreliable, that's kind of like a new one for me. Memory, let's see what else we have. Overused, that's probably true. One of the biggest advantages of the cloud computing plus virtualization, because usually cloud computing runs on virtualized platforms, is utilization to the roof, to the maximum, right? We want to maximize utilization rates. And overused is true. Relaxed, outer space, right? So remember, this is a survey. This is not just the words that I came up with. This is based on what people in the United States think of cloud computing. Sadness, smoke, right? Oh, goodies, hacker's dream, right? So we're getting close to drugs. I don't know what that one comes from. Pillow, joy, heaven and a place to meet, right? And the last one, probably one of my favorites, toilet paper. I don't know why would anybody associate cloud computing with that, but those are actual responses of the people I did the survey about cloud computing. So why so many interesting words in here during this presentation? I'd like to point out that cloud computing word has been, or definition has been abused so much, and being a commercial trainer and certified in cloud computing, I can tell you that it's been overused, it's misused, and I'd like to kind of give you some of the actual concepts of the technologies behind. And as I was flying here, I took a picture of this. Airplanes, most airplanes in the cloud. I'm sure now people will add the airplanes word to the list that I have. So, 51% of Americans think that it's weather related, right? So it affects, the weather is affecting that, and they believe that this can affect the cloud computing, but they know, 29% know that it's weather related. I like these statements also. Have you ever faked it? I think one of the favorite ones here is the 17% actually said and claimed that they know what cloud computing during their first date. That's right. 14% during the interview, the first interview for a job. 22%, this is the, pretended just how it works. And also remember that these are responses from educators as well. There's frequently that I go to conferences where educators also fake it with the cloud computing concepts, unfortunately. 54%, they say they never use it, but actually 95% of people use some kind of cloud service already, whether it's Gmail or Dropbox and so on. And there's the number right there. So, another interesting fact, 40% like cloud computing because they can use it while being in their birthday suite. How about that? And another 35% say that they like it because they don't have to interact with people they don't like. So, obviously this is the name of the survey is the Citrix Cloud Survey. It's interesting to learn from that. If you Google it, it'll come up. I'd recommend you read that. So let's talk about the actual concepts and technologies behind the cloud computing, because now I'd like to start clarifying. Some water maybe? Excuse me. Sorry about that. Yeah, if you don't mind, thank you.
I don't know if there's a water fountain.
All right, so let's start clarifying what's behind cloud computing. let's actually start thinking about technologies behind it. The core pillars of cloud computing would be networks, and you also hear a lot about the thanks, sir. You also hear a lot about the software-defined networking. So I'm going to give you some examples of that later on. Another huge pillar or technology behind cloud computing would be storage. Storage is it just appeared on the desk. Thank you. Storage is also being virtualized, shared, IP, fiber, you name it, but storage is very essential. I would say that if you don't have shared storage, you don't have virtualized environments, you don't have solid cloud computing. And now, I also can tell you that the shared storage concept itself is changing to the point where it's now being localized and then shared. Like if you hear anything like server-side caching and local disks or special cards that you put into commercial servers, and then those cards consist of SSD drives that are being connected through an IP network to another card like that on the hypervisor, they create shared storage for the community of the virtual machines and cloud organizations and so on. So those are kind of like new concepts that were introduced at VMworld. Anybody went to VMworld in San Francisco in August? I did. It's a big conference. Do you guys know about it? It's 23,000 people came here for VMworld. It was in August. It's a yearly event. But anyway, why do we mention VMware? 100% of Fortune 1000 companies use VMware products, and VMware is pretty much leading the way in the landscape of virtualization cloud computing. But things like SSD caching, it's very fascinating. If you get to go to the VMworld, go and visit the exhibits of the industry leaders, and they have up to 1,300 industries that come and present their products and technologies. You can learn a lot. So storage is a really essential player in the cloud computing technology. And the virtualized platform, I don't think it's anything even exciting anymore, I guess. Everybody knows about it and everybody runs it. Whatever it is you use, Hyper-V, Citrix, or VMware, there's plenty of platforms that virtualize hardware. And the way it's done is it's an operating system that's called a hypervisor, and it presents the virtualized layer to virtual machines and so on. All right, so let's continue with the cloud building blocks. So we'll look in a little more with the detail. Hardware, those are the three parts that we talked about: the network, storage, and servers. Mostly it's x86 hardware. That's the most common virtualized hardware platform. And on top of that hardware, we place the virtualization layer. So this is the virtualization layer by whatever vendor, whatever it is you're using, whatever you're comfortable with. And that's kind of like the minimum that you have to start doing cloud computing. And that's probably the data center, the commercial approach to cloud computing, because truly, sharing storage via Google Drive, it's a service, maybe a cloud service, but it's not true cloud computing. It's just a shared resource, right? So if you're talking about cloud organizations there's a secure multi-tenancy of cloud organizations, then you have to have virtualization layer on top of your hardware, and then you start actually putting the cloud layer on top of that. So remember that this is what we need to place the cloud layer on top of it. So does anyone know what goes next after the cloud layer? What do we build? There's some fancy terms that are always floating around. What's SDDC? a software-defined what? Data center, right? So these SDDCs, you can see that I made them into different shapes and sizes. Well, I guess it's the same shape but different sizes. It's on purpose because on top of the cloud layer, we started to define the software-defined data centers. You know what these blocks are? Each one of these blocks is actually this entire layer contained inside the SDDC. So if you imagine these, I guess the virtualization layer and the hardware, these two inside here, that's what we're virtualizing. We've taken the virtualized data center and then slicing it into little data centers of their own. So that's a major transition there, because we're excited about, let's say, VMware data center. We have vSphere, right? Now we actually take that entire environment and build it virtually in the software layer on top of the cloud layer. Yes?
So you're saying the physical hardware is not there, it's just logically separate?
Everything from this layer up is software.
Okay.
All of it. So from here up, it's all software layers, all logical. And one of the key concepts to understand is all the workloads in the cloud are virtual workloads. The cloud layer itself may have something to do with the hardware, with agents running on hypervisors, but the cloud itself doesn't directly command the hypervisors to do anything. It goes through the virtualized layer. It would be a reinvention of a bicycle, let's say. If you would make the cloud layer talk to hardware directly, then why you need the virtualized layer? Because it already does that. And then on top of each software-defined data center, we're building organizations. And today I'll attempt, and the reason why I say attempt is always something that doesn't work, but maybe it'll work. I'll show you the vCloud deployment that I have with the virtual organizations and how they separate with the VMs inside and so on, with its own LDAP and so forth. But again, you see these are different sizes. So what we're doing here, we've got, let's say, two orgs that belong to SDDC1. There's org 1, org 2. Those two orgs could be completely unaware of where they run, how they positioned in the infrastructure, and what logical layer they are. Because from each org, you'll assign specific admins with their rights to create virtual machines, and this thing expands more and more, because every organization can have their own gateways, their own networks, subnets, you name it, anything you want, firewalls, its own LDAP, and basically what you're used to in the data center, imagine that this is a little data center with its own authentication, permissions, infrastructure services, and so on. So now look at this with everything I told you, and think about the term that people use. What about cloud security? I went to Department of Defense Cloud, something secure cloud in Washington, D.C. Conference, which was extremely expensive. And I think 80% of people didn't understand the cloud computing, but 80% of presenters didn't understand what cloud computing is. And nothing against D.C. or politicians or anything like that, but think about everything I told you and tell me, how would you approach cloud security? How would you secure this? There is no answer to that, because you need to start at the certain layers. You need to start at the org layer, you need to start at SDDC, you need to start at cloud layer, virtualization layer, or physical access to servers and so on. So it's really like that universe that I mentioned, because it's so many things inside. If you don't understand how the software-defined networking works inside of each org, it's really, really tough to start thinking about, let's secure the cloud. Right, so
under the cloud layer, can you give me an example of it?
I'll give you a demo and an example. It's a vCloud Director. That's what I use currently for VMware. All right, so what do you think this entire block here, the one that it has a question mark, what do you think this is right here? Like let me rephrase that. What is the goal of doing this here? What are we trying to achieve with virtualization? What's so important, and, you know, I guess, what are the goals of virtualization? What are we doing there? Why are we doing this?
Economies of scale.
Economies of scale, and what else?
Scale economies of scale.
Cost effective.
Cost effective, right? Number one reason why we use virtualization is the efficiency of what? What is hardware?
Resources.
And we call that what? Capital expense, right? So we bought all these machines for this presentation, right, or this classroom, and let's see how effectively we're using this right now. There's zero effectiveness in the utilization of this capital expense. Nothing against City College of San Francisco, but this is the standard approach to hardware. Right? We take this hardware and we deploy it, and then we go, hey, you know, what do we do with this? You know, I'm typing an email, you know, and all of these are power supplies plugged into power source and so on. So, what do you think is this here? That top layer, let's go up from the, I guess not the layer, but all of that. That's right. So now we thought about, you know, I'm so good, I'm 100% utilized, and I'm using all of my capital expenses, all of my investment, 100%. And the question is, how efficiently am I using that? Am I effectively using all of this? Do I know which virtual machines are slacking off? Which virtual machines are, you know, using 100% of resources and they're starving for CPU or anything like that? It's very essential to understand the environment, because people deploy thousands of virtual machines and they don't know what they're doing. Administrators, they have no idea what's going on if they virtualize there, because the mechanisms are not there. You can't confine them to limitations that you want. So that's the OpEx efficiency there, and when we get from 100% utilization, I want to be 100% efficient on that utilization. So there's a technical terminology. I frequently joke, when you go to your next meeting, you know, use these things like, how about the self-service Elastic Portal? You know, use that on your first date. How about that? Right. So I think everybody's familiar with IaaS. You know, platform as a service, infrastructure as a service, software as a service. There's a lot more as a service definitions that you may come across. But here's a test for anybody that claims they have cloud computing. You ask them a simple question, and you can quote me on that. You ask them, what is the self-service portal that you're using for your cloud platform? That's what you ask them, because this is the major aspect of cloud computing. Self-service portal. What do you mean self-service portal? You don't run cloud computing. That's a simple test you can do, because people frequently confuse virtualized data centers with the cloud platform. Everything is a cloud right now, even Delta Airlines, right? So what's so important about self-service portal? When you take, let's say, do you mind if I borrow this? You get an email or a sheet of paper from somebody and they say, here, create these virtual machines. And you're the admin that creates those virtual machines. You know what that is? That's a virtualized environment. That's not a cloud environment. In the cloud environment, users go to a web page and pick a service catalog that they want, pick the virtual machine that they want, and say, I want that. And in 10 to 30 minutes, they get their virtual machine self-deployed for them. And the admin just says, yeah, I'm okay with that. Let them go. So that's the self-service portal with the service catalog. It's very important because the service catalog is another major aspect of cloud computing. In the service catalog, you can have things like, let's say, an entire SAP environment as a single object. Right? So you take that and say, I want that, and it deploys 5 virtual machines that have SAP. Or you want a VMware lab or AMC lab, and you say, I want that. I have 2 more students in my class, and you deploy that single object that contains 10 virtual machines. It's right now it's up to 128. So every VApp, the logical container, can have 128 machines, and that's a single instance in the service catalog. And somebody said elastic. What's the difference between elasticity and scalability? Because there are 2 different things, right? Scalability goes up, doesn't go down. Elasticity up and down. What it means is that you can request 2,000 megahertz today and 200 tomorrow and pay just for that. But if let's say you bought 40 machines for this classroom, it doesn't scale down unless you start throwing these things out of the window. That's the scaling down. If I rewind back to here, these things scale up and down. If I want to pay for this big circle today, I will do that. But if I want to pay for a little circle tomorrow, I'll do just that. It's like a utility bill. So that's the essence of cloud computing. Secure multi-tenancy, that means all the tenants, all their work, they sit together, and there's no interaction. They can't go into each other and attack each other. They don't even know they exist. It's not even software separated. There was never software connected, right? If you can put it that way. And then there's secure private hybrid community clouds. I recommend that you look at the National Institute of Standards of Technology definition for cloud computing. Just Google NIST cloud computing. There's a lot of really good documents titled SP-500, SP-800. I'm in the working group with the NIST for security of the cloud computing. There's new documents that just been published in the past month, and there's a lot of interest as a public knowledge. So let me give you an example here of the cloud layer. Right, this is the vCloud Director. This is what I use, and that's what I'm certified in. But there's other things like Amazon and OpenStack and so on. So a lot of things are involved here. I'm not going to go through all of them. vCenter, that's the virtualized layer. vCloud Director installs agents on hypervisors. It has to have a database. But most importantly, there is the self-service portal. Right? This is where all these users, instead of emailing you and knocking on your doors, create this virtual machine, delete that virtual machine, they go right here and manage it. So I'm going to do a quick demo of that. There's a link here, cloud.georgetown.us. That's a domain that we registered for, kind of like what I do with Georgia Southern. And let me see if I can go into right here. By the way, if you haven't used Google Remote, I recommend you use Google Remote. Bypasses anything. Like they log me in here, but if you use Google Remote, it just goes straight through HTTP without anything, just from the browser. Don't talk to your network admin. Tim? Let's see, I think it's... So what I am doing right now, I'm logging into, I think I'm logging into. Okay, so this is our domain that we use. I'm going to zoom in on this, vcloud.georgetown.edu. Right now, you see these orgs that I've created. This is our partners that I work with, and Ramon is contributing to that a lot. Ramon is also vCloud certified. Ramon is probably hearing me right now because he should be connecting their remote session. So what are these? These are the orgs that you saw, those circles, right? These are the circles that sit on top of the provider VDC, so-called. I'm starting to use the vCloud terminology here. This provider VDC is a software-defined data center. So inside of the software-defined data centers, we create the organizations. So let me go to one of these things, like let's say, which one would be a good example?
What's the size of those organizations? Is that something within your campus, or is that something like two or together?
Anything you want. Remember scalability up and down. As an admin, you are creating, I'm trying to see the one that has some good VFs. Let's say computer science. Elasticity up and down, you can do anything. So let's say right now I'm in the computer science department. There's a professor I work with. He asked me to, provide a cloud for him. Remember, this is a browser-based, Flash-based plugin only, no install really required. So right there, he has a virtual machine that's running, and there's the networking for the machine. I can create any gateway, any firewall, any DHCP, DNS you want for that just VF inside the org. This thing grows exponentially inside the orgs. We have virtual machines that are logical containers inside of VFs, right? So it gets pretty complex, but example here, let's say I can, well, this one is shut down. I can right-click on this, and let's say I can insert the CD from a catalog, right? Your students always ask, where do I find the ISO? Right? Or your users. Right there, right-click on the machine, insert from catalog. What do I have here? I've got some machines like Linux, FreeNAS, Windows, so on. They insert that right from the catalog. The org admin places those in the catalog, and they can just insert it and install if they want. They can copy from catalog. They can have pre-built machines if they want. If you, let's say, you passed the point where you teach people how to install operating systems, you just tell them, copy this. It's a ready-to-go virtual machine, Windows 7. Right? This org itself, this is just a VF for the organization. But if I go to the administration of the organization, this is really, really powerful. This is self-generated, based on the name you create, self-generated HTTPS access to the org. So when I create this, I email this link and say, there's your credentials, log in, start creating your VMs. And this thing can also have its own LDAP, email services, policies that you set for resetting passwords and so on, other stuff. But basically, if I log in as the computer science department, he won't see that all the cloud interface that I manage, let's say I pretend like I'm Amazon, that person won't see that, but they will see their own URL. They'll pretty much see this page where it says my cloud with my virtual machine and so on. They can start working with that. So that's a quick demo. I'm going to keep it open. I'm going to do a couple more slides because I think, what do we have, like till 12, Tim?
12:20, that's probably about 12 more minutes.
Okay, then I'm going to do a little more demo, and then because I think demo is one way to do this. I'm going to go to the system, and right now, this cloud layer, entire layer, has all these organizations that are based on some provider VDCs, right? So I define how I slice up the virtualization layer. As a cloud admin, as the provider admin, I can specify what size of the hardware is going to be allocated for which organizations. Right now, these sit on, I think, like 2 provider VDCs, but basically the provider VDCs then become logical containers on the virtualized hardware. And we can specify vCenters that connect to it, hypervisors that connect to storage profiles. For example, if I go to here, right now there's only one storage profile, and I call it gold, but it tells me how much is provisioned, how much is used, and that's coming from the virtualized layer, all this information. And let's see what else I can do here. Edge gateways, right? These gateways, this is probably an old message. We're relocating things, but I can clear these events. So these gateways, this is when we start talking about the software-defined networking, and I'll give you some specific examples. These are virtual machines that can do anything you can imagine in the software layer with the networking. Anything. And I'm not kidding you. So let me get out of this and go back to here. And since we're talking about software-defined networking, this is the next slide. This is copyrighted by VMware. It's coming from the commercial slide, so don't just freely claim it's yours if they share this. Hardware resources, physical networking, firewalls, all these things that we're worried about, right? You'll be worried about this a lot more once you know what you can do here. I'll tell you that. But on top of this, we place the hypervisors, and hypervisors virtualize platforms, and then they create virtual networks. Right? It was really exciting that I can have like a Nexus switch that is really, you know, it can do anything I want, port configurations and so on. Well, guess what? The software-defined networking now has machines that virtualize this. You don't have to have a hypervisor to virtualize it. The software-defined networking appliances, they actually virtualize this. They say, where is the door to the outside world? Right there. And I can do all my networking logical, right? So it's like a hypervisor for the networking hardware. Be prepared that you will no longer configure these devices extensively, right? So these networking hardware devices, and you probably be like, how is this possible? It's very possible because all the signals that come to this device will be pre-configured firewall, port forwarding, and you know, DHCP, whatever you want. And I'll give you examples of this. And right now, the vCloud Director, what it does the org networks that we create. Inside the org networks, I can create vApp networks just for the VMs that talk to each other. You don't really talk. I mean, you can make orgs talk to each other if you want to, but essentially, let's say City College of San Francisco wants to have a LAN, right, local area network. That would be just one org network right there in the vCloud Director. And you create that layer, and then you place vApps on top of that layer. So you see how it grows? It's really, it's pretty complex, I guess. So let me give you examples. How is it possible not to configure physical switches, right? I'm not proposing that you should like abandon them, just plug it in. You should still do some basic administration, like change the default passwords and so on. But for example, like this is the it's an example of port forwarding right there, right? This device here that you see, this is the entity that virtualizes networking. This is the software-defined appliance, and that appliance creates gateways, creates port forwarding. For example, if I want to go from the 80 to TCP, let's say from the 8080 to 80 on the internal network, when the requests come in, they hit the appliance here. That's a virtual appliance, a virtual machine. This thing forwards all the traffic to a completely different subnet. Right, so this is very typical what you do on the hardware layer. So why do this on the hardware layer if a virtual machine can do that? Think about that. Right, this could be your real network. This is the network that is kind of hidden from the world. This is really cool. This is the destination net. Let's say an ARP request comes in, and it's asking for a 204 address on this network, right? The reply comes from the vShield Edge device, and it says, I have that, which is not true, but what it does, it sends the request to completely different subnets to the machine, and anything unsolicited on the outbound traffic, it doesn't match the firewall, is blocked by this device if this machine wants to chat, right? So all software defined. Think about, if you're teaching networking, this is gold for you, ladies and gentlemen.
So you're no longer worried about the subnet list. It does it.
You no longer really worry about configuring the hardware,
Okay.
right? Because what you can do, you can just say, give me an outside port, and I'll send all my traffic through it, right?
Say something about how this might apply to real-time applications where jitter and latency are an issue?
Well, you know what? This is a great question. Do you know the speed of these communications here on the software-defined layer? Can anybody guess who wants a gold star? What's the speed of communications in the software-defined networking?
Wires.
Who said that? Gold star for you. CPU speed. There is no match to the CPU speed in any network switching. So basically, all of this is done in milliseconds. And everything else, once it hits the hardware switch, it's as fast or as much money you have, right? So it depends on what goes out there after that. This is really fast because people done some testing. Like I teach at the Research Triangle maybe once, twice a year with the Cisco engineers, and they say, we've tried to put the ISO image on the super fast, the best Cisco switch. It still doesn't match if you put it inside the virtual machine on the virtual switch.
It's hard to believe. It's hard to believe that virtualized software can outperform software on a chip. I don't.
Well, it's, you know, just compare CPU to whatever hardware you have. It's not, you're thinking in terms of software versus hardware chip on the switch. Think in terms of CPU speed versus whatever speed on the hardware on the switch. That's the difference. Because it's all in the switch, is still software that hits the hardware, right? It's the same concept there. Not impressed?
I'm not impressed. I believe you. It's just hard to believe.
Well, it's like you insert a 16-core CPU into a Cisco switch. That's it. Because it's all software that taps all that traffic. You just put the super hardware in the switch, that's all.
How do you have to troubleshoot this thing?
This is where you need a lot of training, because this is once you get into these things, it's really, really hard to start understanding the layers of where you are. This is really tough, but it's not harder than managing Cisco switch with a serial cable. It's much easier than that. I can tell you that because it's all from one space, browser based. Another example here, we've got this is port. This is IP masquerading. Anybody heard of IP masquerade? This is really interesting because all your traffic that you want, you can make it look like it's coming from one port. And internally, you can issue whatever IPs you want, and it's not like a proxy because it doesn't use anything but one IP address externally. So you can, all the network admins, right, Tim? Isn't this brilliant? It looks like one IP, one port, but it's like, 1,000 machines sitting behind that. Another example would be, I have 5 minutes left. Another example would be like, this is brilliant. This is called the VF fencing. How do you make, let's say I clone this and this VM into this and this VM, identical MAC addresses, identical IP addresses. How do you make them talk? Not possible in the physical world, right? You have to configure the VMs in the physical world. In this world, you don't have to, because what I can do, I can issue individual IP addresses to these machines because this device can do it. What it does, it creates an individual IP address. This machine talks to that one, thinking it's a completely different IP, different map.
Like a different subnet in the hardware world.
Yeah, it's a different subnet, but also different MAC addresses, because the reason why we have this is really, really good when you clone thousands of machines. You don't do on the OS level anymore anything. You don't do anything here. You don't configure these guys. You just say fence this, and there's the IP, issue these IPs. So that's pure software-defined network. All right, next level, because that's why I changed from next to current, remember? Right? What's next? vCloud automation. The universe of the universes, right? How do you manage different cloud layers? This is the, you'll hear different names for this. It's called the VCAC. Some people say, I've heard a person with a British accent say VCAC. There's a vCloud Automation Center by VMware. Amazon is probably beyond this, because Amazon, like 3 or 4 years ago, Amazon was doing as much, actually twice as much cloud computing as everybody combined, by the way. You know, everybody who claims Verizon, Google, everybody. Amazon is a monster in this, but vCloud automation, what I can do, look at this. You see these? Citrix, KVM, hypervisors, right? Serve the Hyper-V machines. Any type of, well, I shouldn't say any type, specific type of hardware. Amazon Web Services, what I can do, I can take and deploy and manage machines into Amazon, from Amazon to Hyper-V, from Hyper-V, vCloud in and out, and so on. And it's all browser-based. You go into this massive browser-based interface, and you can start deploying your machines into any cloud layer. Again, I shouldn't say any, but many cloud layers, because it's really hard to accommodate everybody, but this is pretty massive. So on that note, summarizing all of this, I call it the overused mysterious network innovation in outer space. Right? You can come up with your creative words, but this is our addresses if you want to talk to us. Thank you, and I'll take questions if you have them. Be happy to answer.